Hello everyone, myself Ravi Bhavani Sai Kumar, working as an assistant professor, Department of Civil Engineering, Sesi Institute of Technology and Engineering, Tadepallipuram, West Godavari District, Andhra Pradesh. I welcome you all for an introduction section on the course Advanced Concrete Technology. So, the name of the course is Advanced Concrete Technology. Prerequisite for the course is Building Materials and Concrete Technology. The targeted audience are for undergraduate and postgraduate students. So you can see around the world, almost more than 60% of the structures are built with concrete only. You can say as an reinforced concrete structures, starting from residential buildings, household complexes, hospitals, education institutions, and several bridges which are main for an infrastructure development of a country. The concrete plays a vital role in all these structures. You can see from the picture representation a bridge which is constructed by using the concrete. And you can see from the picture representation the concrete which is taken from mixture is placing at the site by the workers at the site. And from these two picture representations, you can see uh, the workers are working with the concrete at the site after it has been designed and batched to the design, batching, and sent to the respective construction site. Our advanced concrete technology course is divided into 5 modules. We will see what are the contents we are going to learn in each of these 5 modules one by one. Coming to the module 1. So the major objective of the module 1 is we are going to learn the fundamental concepts of box compounds and the structures of cement. So we know that concrete is a proportional mixture of binding material, aggregates, water, and admixtures. So before having overview of entire concrete as a material, we want to know individually the properties of each and every ingredients of concrete. So one of the major ingredient of concrete is cement, which is acting as a binding material. So after heat of hydration, we can have the box compounds. Major 4 box compounds are formed. We need to study the box compounds in detail because the box compounds plays a major role in the behavior of concrete and thus affects the behavior of the concrete. And then another topic is we are studying about the structure of hydrated cement paste. The structure which we are going to study is of the cement is of the reaction of cement with water and the volume and the porosity and the transition zone. And we are going to study what are the factors that are going to affect strength and elasticity of concrete and rheology of concrete in terms of Bingham's parameter and the elastic modulus also. So these are the sum of topics which we are going to cover in module number 1. So we can have the basic idea of the structure of hydrated cement paste and the importance of box compounds and how they are going to affect the cement and thus affect the concrete properties. We can learn detail in these modules. So after completing the module, we can understand the fundamental concepts of the box compounds and the structure of hydrated cement paste. Coming to the module 2, in the module 2, we are going to learn the concept of admixtures and different types of admixtures in detail. So as I said earlier, apart from basic ingredients which are used in concrete, we are mainly using one of the admixtures to increase the strength or workability or the characteristics of concrete as per the need. So for that, we are adding admixtures to the basic concrete ingredients. So under heading of chemical admixtures, we are studying both chemical admixtures as well as mineral admixtures under the heading of module 2. So in the chemical admixtures, we we are going to study about what are the mechanism and the plastages and superplastages and their behavior and their effect on the properties of concrete. They're both hardened as well as state, and what is the optimum content or dosage which we need to provide it as a superplastizer to the concrete ingredients. And we need to study about retarders. Retarders in the sense, if you want to slow down the process of setting time, we can use retarders, or if you want to increase the process of setting time, we can go for accelerators and different area training admixtures and new generation superplastazers. We are mainly concentration of superplastazers and plastazers and retarders, accelerators, and area training agents as admixtures and a heading of chemical admixtures. When coming to mineral admixtures, in the mineral admixtures, we are mainly concentrating on fly ash, silica fume, GGBS, and the effect on concrete property in both fresh state and hardened state. The admixtures plays a vital role in the concrete design. So admixtures adversely affect the behavior of concrete in both fresh state and after hardening state. As I said earlier, the main aim of admixtures is to increase the performance of concrete according to the requirement. After completing the module number 2, you can gain some basic concept of admixtures and different types of admixtures and how they are going to affect the properties of concrete. In the module number 3, we are mainly going to design mix design process. So, as I said earlier in the opening slides, concrete is an proportionate mixture of the concrete ingredients. That is, concrete ingredients, the binding material, aggregates, cement, and admixtures. So, in the mix design concept, we are going to proportionate the concrete ingredients, and we are ultimately calculating how much quantities we need to be taken for designing of a particular concrete mix design. So, Bureau of Indian Standards proposed one code IS 10262. Based on that code, we are designing the concrete mix design. So, on the concrete design process, there are several grades of concrete starting from M5, M10, 15, M15, M20, M30, and M35. We are mix designing these concrete mixes according to the Bureau of Indian Standard Code based on IS 10262, and also we are using American Standard Code and British methods for mix design process. And also we are learning what are the factors that are affecting the process of mix design. So properly designing a mix design help us the concrete to attain good strength, and a structure can last long for an maintain durability. After completing the module number 3, you can understand the basics of mix design and its application, and how to design the mix design based on the above said 3 codes: Indian Bureau of Indian Standard Code, Indian Code, American Code, ASI Code, and British Code, BS methods. Coming to module number 4, in the module number 4, we are mainly looking about the durability concept. Durability concept is one of the important concept in the concrete. The structures which you are daily seeing are exposed to a severe environment conditions. Some of the structures may be near to seashore. Some of the structures will have industrial operations. So, and some structures have adverse effect of environment will affect the adverse effects of the environment. So, the concrete which we design and given a shape of a structure should resist all the adverse effects of the environment and should go on its serviceability or its life period. So, if the concrete is deteriorated before its lifespan due to the adverse effects of environment, let us say chemical attack or acid attack, or due to corrosion of the embedded steel reinforcement or sulfide attack, we need to study its process and how we can protect the concrete structures from deterioration process. It all been studied under the process of durability. The durability module we are studying about is introduction of durability and permeability of concrete, and the chemical attack of concrete, chemical attack on concrete structures, and acid attack on concrete structures, fluorescence, and corrosion of reinforcement bars in the concrete, and thermoconductivity, thermal diffusivity or specific heat, and alkali aggregate reaction. So alkali aggregate reaction is the most important concept where the alkali content in the cement, which is a binding material, reacts with the aggregates and some processes happen, some additional compounds of forms which obviously affect the properties of concrete. That is studied under heading of alkali aggregate reaction. And the durability of concrete is within limits of IS 456 2000. We need to study what are limits and how the concrete is going to behave. All these points are mentioned in the respective code. After the completion of module number 4, a student will able to study the durability of concrete. In the module number 5, we are going to study about different tests on the hardened stage of concrete. So in earlier times, we are going to use the conventional way of concrete by using compression testing machine or flexor machine to study the strength-based parameters of the concrete. It's a non-conventional, it's a conventional way where we need to take the cores from the structures and we need to put in a machine of compression testing machine or flexor machine, testing machine, we need to be carry out test and the core element will be automatically breakdown upon taking out the loads. Whereas in the latest technology methods, we are using several non-destructive testing without taking the cores from the structural elements so that the structure can be as it is and we cannot break, there is no chance of breaking the structures. So in the model number 5, we are studying about both the conventional methods as well as non-destructive testing in detail. Non-destructive testing methods includes V1 hammer test, ultrasonic pulse velocity test. After completing the model number 5, you can understand the performance of different tests on hardening concrete in detail. Thank you. I hoping to see you all for the course. Thank you.